Good morning, students. In last class, we discussed about the special purpose electron device. In that, we discussed the tunnel diode. Today, we will discuss some of the special purpose electron device. In that, we will discuss varactor diode and Schottky barrier diode. First, we will discuss varactor diode. This varactor diode is also called varicap or tuning or voltage variable capacitor diode. It is a junction diode with small impurity dose at its junction, which has the useful junction capacitance or transition capacitance, which is varied with the voltage. We know in normal diode the depletion region exists between the P region and N region. We can observe in the diagram here P and diode and P region and N region. So this P junction diode offers the capacitance, transition capacitance or spare charge capacitance or barrier capacitance or depletion capacitance in the reverse bias. We know it is represented with CT is equals to epsilon A by W. Yes. So here epsilon is the permittivity of the semiconductor and A is the cross section area, W is the width of the depletion region. Yes. So the capacitance is varying according to the reverse bias voltage of P junction diode. Here this P region and N region acts like the plates of the capacitor, while the depletion region acts as dielectric material. Yes. So when diode is in reverse bias, the depletion region formed, you know this one. The larger the reverse bias applied across the diode, the depletion layer W becomes wider. By decreasing the reverse bias voltage, the depletion region width W becomes narrow. Yes. So this depletion region width is inversely proportional to the transition capacitance CT. Yes. When reverse bias voltage increases, depletion region width increases, then transition capacitance decreases. In short, we can say the capacitance offered by the diode is controlled by the applied reverse bias voltage. Yes. So the variation of transition capacitance with respect to the applied reverse bias voltage we can observe in the graph. So when are increasing the reverse bias voltage, the transition capacitance decreases. Yes. This is one of the special type of diode, so which are manufactured to get the transition capacitance property more predominantly as compared to the normal diodes. That's why we are calling the diodes are varactor diodes, varicap or tuning diodes. The doping profile of these factor diodes is hyper-abrupt. Coming to the doping profile of normal p-n junction diode is abrupt only. In hyper-abrupt means the doping level increases towards the junction. This produces the very narrow depletion region and larger capacitive effect. We know in normal p-n junction the doping profile is constant throughout the p and n region. As it is called abrupt junction. In the hyperabrupt, the doping concentration is more at junction and it is gradually decreasing when it is moving from the junction. Yes. So here doping concentration is more at the junction. That means the depletion region width is very small. Yes, the depletion region forms at the junction. So when doping is more, depletion width is very small. So for the narrow depletion region width, it offers the larger capacitive effect or larger transition capacitance. Yes, this capacitance is vary more dominantly with reverse voltage in such diodes. Yes, so here we can observe the doping profiles for abrupt and hyperabrupt junctions. In hyperabrupt, it is constant through the diode. In the hyperabrupt, it is more at the junction and it is decreasing towards the P region and N region. It is moving from junction to P region and N region. Yes. What are the applications of varactor diodes? These varactor diodes offers the larger capacitance. Means at 0 volts, the varactor diode depletion region is small and capacitance is large. It is approximately 600 picofarad. Yes, so it is like a capacitor and it is varied electronically. That means it is varied with respect to the voltage. These varactor diodes are used in the tuned circuits. Means the tuned circuit is always consists capacitor. Instead of capacitor, we are using the varactor diode. So varactor diode is like a capacitor. So in tuned circuits, it is used. So tuning means varying the capacitance. Yes. So here the capacitance is varied by using the varactor diode, and it is also used in the FM modulators or FM radio, frequency modulator or frequency modulator radio, and automatic frequency control devices. And these vector diodes are used in the adjustable band pass filters. So in all the applications, we are instead of using capacitor, we are using the varactor diode. Yes, in tuned circuits we are using capacitor. In FM modulators we are using capacitor. In automatic frequency control device we are using capacitor. Adjustable band pass filters we are using capacitor. Instead of capacitor we are using the varactor diode. So it is this capacitance is varied electronically, that means it is varied with the applied reverse bias voltage. Yes, and we can say these vector diodes are also used in the LC resonance circuits in microwave frequency multipliers. Yes, so here we can observe the vector diode symbol. It is like normal p junction diode, but it has the capacitance symbol and it is variable symbol. So this is variable capacitance with respect to the applied reverse bias voltage. About the Schottky barrier diode. A Schottky barrier diode is also known as Schottky or hot carrier diode. The Schottky diode is nothing but metal to semiconductor junction. Yes. So normal p junction diode or vector diode or tunnel diode. In all the cases, we consider the junction is found by using the two semiconductors. That means semiconductor to semiconductor junction. But here, Schottky barrier diode is formed by using the metal to semiconductor junction. So, a Schottky barrier diode is a metal to semiconductor. Here, this junction is formed by bringing the metal contact with a moderately doped n-type semiconductor material. The Schottky barrier diode is a unidirectional device conducting current flows only in one direction. That means conversion current flows from metal to the semiconductor. In normal p junction diode, current is moving from P to N and N to P. And in normal p junction diode, current is produced due to the positive charge carriers and negative charge carriers. That is bipolar and bidirectional. Here in the Schottky barrier diode, the current flows only in one direction from metal to semiconductor. Yes, and here the charge carriers is only electrons. In metals we are having the majority charge carriers are electrons. In n-type semiconductor is also we are having the charge carriers are electrons. So here it is a unipolar, unidirectional, unijunction diode. Yes. So here we can observe the Schottky barrier diode symbol and its structure. Yes. So here metal terminal is called anode and n-type semiconductor metal terminal is called cathode. The Schottky diode is related directly with the temperature doping. In n-type semiconductor, decrease and increase of temperature doping concentration happens. We know this one. Yes. So this doping concentration is depends on the temperature. Yes. Between the semiconductors metals junctions, depletion layer formed known as Schottky barrier. So initially here it is a metal and semiconductor. We don't have any barrier. We don't have any depletion region. But in the n-type semiconductor we are having the large number of electrons. In metal we are having the electrons. These n-type material large number of electrons are moving into the metal. Then what happens? Here we are having the positive ions in entire material, and whatever the electrons enter from n-type to p-type material, enter from n-type material to metal, that electrons are accumulated near the junction, and the immobile charge carriers or positive charge carriers that are present or near the junction that forms the barrier. This barrier is very small value. Yes. So the depletion layer between the semiconductor and metal junction is called Schottky barrier. So in this metal, mostly we use palladium or tungsten or gold or chromium materials. And these Schottky diode working or operation, when this Schottky diode is unbiased, that means when we are not applying the any potential to the Schottky diode, that means anode terminal and cathode terminal. Anode means metal, cathode means entire semiconductor. Electrons accumulated on N side will have lower energy level than electrons present on metal region. Due to this, electrons cannot flow across the Schottky barrier, so there is no current. We know it is common in all the cases. Yes. When it is connected in the forward bias, that means the negative terminal of the battery is connected to the N-type material and positive terminal of the battery is connected to the metal, that means anode. It is nothing but forward bias condition. An electron present in the N side receives the more energy to cross the junction barrier and enters into the metal. Due to this, electrons are called hot carrier, as diode is called hot carrier diode. In this we can get the current. It is forward bias current. Yes. So here when we are connecting in the forward bias, to start the conduction, to cross the barrier, to cross the Schottky barrier, these electrons requires the very small energy. That means the voltage drop in the Schottky diode is very small. It is about 0.15 volt to 0.45 volt only. Coming to the normal penetration diode, we require the 0.6 to 0.7 or zero point 0.8 volts. That means the voltage drop in the normal penetration diode is 0.6 volts to 0.7 volts. But coming to the Schottky diodes, voltage drop is 0.15 to 0.45 volt. This is the advantage of Schottky diode. Why? Because when we are having the lower voltage drop in the Schottky diode, the power dissipation in the diode is very small. Why? How? So power dissipation in the diode can be written as V into I. So here voltage drop is very small. When you are considering a current passing through the Schottky diode, the current into voltage drop in the Schottky diode is small. So power dissipation in the Schottky diode is also small compared to the normal penetration diode. Why? Because in normal penetration diode, voltage drop is about 0.6 to 0.7 volts. Here it is 0.15 to 0.45 volts only. So this is the main advantage of Schottky diode. So the power dissipation is very small. So it is used in the higher efficiency applications. Why? Because where we require the less power dissipation. Yes, and when you are connecting the this Schottky diode in the reverse bias, that means under reverse bias condition, that means the positive terminal of the battery is connected to the n-type material and negative terminal of the battery is connected to the anode or metal material. Then what happens? The width of the depletion region increases. Therefore, the current flow stops in the Schottky diode. In the metal plate, there will be more number of excited electrons. Why? Because here we connected the n-type negative terminal of the battery to the metal, so there are more number of electrons are excited in the metal. Due to this, there will be flow of small amount of leakage current. So we connected the negative terminal of the battery to the metal, so that electrons are excited more, and some of the electrons are crossing the depletion region, and it is nothing but leakage current. It is very small. Yes, when reverse bias voltage increases further, current also increases due to weak barrier. Yes, when abnormal increase in the bias voltage takes place, then what happens? We know when I increase the more reverse bias voltage, suddenly current also increases in the diode. It is nothing but it breakdown, reverse breakdown. Yes, in this case, sudden current will flow in the Schottky diode, then device will damage. Yes, this is called breakdown voltage, the Schottky diode. Yes, and characteristics of Schottky diode. So it is looking like our normal p diode, but the only difference is the cut-in voltage is very small in the Schottky diode. I said it is 0.15 volts to 0.45 volts. In normal p junction diode, it is 0.6 to 0.7 volts. So due to that, the power dissipation is very small. So in forward bias, it is similar to the normal p junction diode. And coming to the reverse bias, here it is looking like normal p junction diode, but in Schottky diode, we are having the more leakage current. That means reverse saturation current is more compared to the normal p junction diode. So here the graph is looking like normal p junction diode, but in forward bias, cut-in voltage is very small in the Schottky diode. It is about 0.15 volts to 0.45, and in reverse bias, reverse saturation current is more compared to the normal p junction diode. Okay? The applications of Schottky diode is, it is common. It is like a switch. It can be used as a rectifier spy because it performs the normal operation of creation diode. Yes, and it has the lower power dissipation, so it is used in the high efficiency applications. And here the switching speed is more, so it is used in the fast switching applications or circuits. And this Schottky diode is used in the TTL logic families, Schottky TTL logic family, that means transistor logic. So I think you studied in the digital electronics. It is one type of logic family. So in that, Schottky diode is used. These are the applications of Schottky diode. Thank you.